Good morning children. Welcome back to physics class. Lecture number 4. Chapter number 1. Reflection of light at curved surfaces. How are you doing children? I hope you all are doing good. In last class we have learnt reflection of light at curved surfaces and how to draw the ray diagrams for a concave mirror, and we have learnt rules to draw the ray diagrams. And 4 cases we have discussed. In last case number 5 I gave you homework. Case number 5 is, if the position of the object is beyond C, what is the nature of the image, and draw the ray diagram for that case. See, here we have seen different positions. In the first case we have seen when object is placed between P and F, between pole and focal point we have seen. The next case is when object is placed at F, what is the nature of the image we have learnt. And if the object is placed between F and C, what is the nature of the image we have seen. And if the object is placed between on C, what is the nature of the image we have seen. Now the last case is, if the object is placed beyond the C, what is the nature of the image. I will discuss once again what we have learnt in previous class. For the different positions of the object, how do the images changed, the nature and the size characteristics of the images we have learnt. Let's once again we'll see what happened and what we have learnt. When object is placed between P and F, the nature of the image is enlarged, virtual, erect, and the position of the image is behind the mirror. And this case we used in different applications. Example, shaving mirrors, car headlights, even dentist, the mirror used by dentist, we used that application. And the next position, if the object is placed at F, the nature of the image is infinity, the image formed at infinity, and the size and the nature do not discussed, as it is forming at infinity. We do not predict what is the nature. And the next case is, maybe it is enlarged, virtual and erect only. And the next case is, if the object is placed between F and C, the nature of the image is image formed beyond C, and the nature is it is enlarged, real and inverted. Image is real and inverted, enlarged in size. That means the size of the image is more than the or greater than the size of the object. And now the case is beyond the C, and if the object is placed at C, the image also placed on C only. In last class we have learned that object is placed on C, image also on C only. The size of the image is same size as the object. These are the ray diagram. This is the ray diagram. And the last case, as a homework it is given, if the object is beyond C, the size of the image is less than the size of the object, that means diminished, and the image we get between F and C. Image is formed between F and C. How to draw this? Take a ray which is parallel to principal axis. You can see here it is in blue, passing parallel to principal axis, passing through focus, it is in pink. Reflected ray is in pink color. The other ray is taken, passing through the focus, and it is parallel to principal axis. These two rules are converse to each other. Both of the rays are pink colored rays are reflected rays. The point where the two reflected rays meet, there we get the image. This is the intersection point of two reflected rays, so we get image here. Image is denoted as I dash because the image is the image is real and inverted, and here object is denoted as O dash. This is our homework. Today's topic for this class is derivation of mirror formula. See, there is a relation between some distances here in this chapter. What are those distances and why mirror formula? Generally in daily life we use mirror for different applications. Applications as we discussed now. We use in rear view mirrors, we use in car headlights, we use different mirrors in solar cookers, we use for shaving mirrors also, and we can use all traffic signals also we can see, and we can you see in shopping malls also we can see that concave mirrors are used. For different applications we use different purpose. To use the particular mirror for the particular purpose, what kind of purpose, For what kind of purpose, which mirror should be used. To know this, we need to understand one point here. What is the size and how the size of the image increases or decreases. To know this, we must have some relation between some distances, and we must have a sum of formula. See, in linear equations, you will have 3x plus 2y is equal to 4, or 2x minus 3y is equal to 6. Calculate the find x and y values. So we will solve x and y values. If you know x value, substitute in form equation 1 and you'll get the y value. So like this, we have some relation between some terms. What are those terms? Object distance, image distance, focal length, radius of curvature. These are the 4 distances. I repeat, there are 4 distances in mirrors. To get the image size, what is the size, how much size it will be. So what kind of size we require for this particular purpose, how much this see, in plane mirror we get the same distance of the image also. For example, in front of the plane mirror, if you stand 1 meter away from mirror, then you will see the image also 1 meter away inside the mirror. So the image distance and object distance both are equal in plane mirror. It's unlike in concave mirror. Concave mirror and convex mirror do not produce the same object distance and same image distance. We do not get. Both of them are completely different. So where do we get the image? If image is very far, when we don't know where we should use a mirror. So to know the image distances and to know what is the size of the image, how much size it is required to know. So these all the things can be calculated by using some formula. That formula is called as mirror formula. Mirror formula is giving a relation between object distance, image distance and focal length. We say U, V and F. U is nothing but object distance, V is nothing but image distance and F is the focal length. So to know this relation, we need to derive a mirror formula. Mirror formula is nothing but 1 by F is equal to 1 by U plus 1 by V. This is formula, and to derive this formula we have here ray diagram. To study the ray diagram, before study the ray diagram, let us learn some sign conventions are there to understand, to get the derive the formula. What are those sign conventions? Sign conventions are nothing but, see, this is the image, and image is sometimes formed in front of the mirror, sometimes in behind the mirror. So we have different positions of the mirror. So this is very important to calculate according to the geometry the signs. Positive sign, suppose in coordinate geometry we will have x-axis, y-axis, positive axis, negative axis, first coordinate, second coordinate, third coordinate, fourth coordinate, plus, minus. Like this we have different sign conventions in geometry. In the same way, in mirror formula also, while using mirror formula we need to follow some sign conventions. So not only in using the mirror formula, to derive the mirror formula also we need to know the sign conventions, so that we can derive the mirror formula. So before going to derive the mirror formula, let us see what are the sign conventions. And the sign conventions are completely talking about only 4 distances. Those distances are object distance, image distance, focal length, and also height of the object, height of the image, radius of curvature. These are the distances the sign conventions talking about. So how to take the sign conventions? Let us see. The first point of the sign convention is all the distances must be measured only from the pole. All distances must be measured only from the pole. So what are the distances in the ray diagram? Let's see. Suppose this is a pole, right? This is a pole. The distance between pole and focus is called as focal length. The distance between pole and focus is called as focal length. The distance between pole and center of curvature is called as radius of curvature. The distance between pole and image is called as image distance. The distance between pole and object is called as object distance, right? These are the distances, and these distances how to take? We cannot take always positive and always negative, no, because in this case all are forming here only, but in other cases, like in the first case of concave mirror, we get image behind the mirror. At that time, how to take the distances? How to take positive we should take or negative? So all these things can be learnt by using the sign conventions. The first rule of the sign convention is, let's see here, all the distances must be measured only from the pole. All the distances must be measured only from the pole. All the distances must be measured only from the pole. All the distances are nothing but, I told you before, focal length, center of curvature, radius of curvature, image distance, object distance. These are all the distances. If the all the distances must be measured only from the pole, that is nothing but all the distances should be measured from the pole. That is nothing but, if we consider this is a pole, from pole focal length you should start from here and you should end this pole to focus, that is focal length. You should start from here only, and radius of curvature is from pole to center of curvature is radius of curvature. So the distance radius of curvature must be again start from only pole to center of curvature. For example, this is object, okay. If you want to find out the object distance, you need to start from only from the pole. And if you want to find out image distance, this is image, so only from the pole you need to measure the distances. So this is nothing but all the distances should be measured from the pole. The next case, the second case I am telling you, with the help of a ray diagram I will tell you, so that it will be easy to understand. The second rule is telling, if the distances value measuring from the pole, those distances if they are along the direction of incident ray, then it is considered as positive. If the distances are opposite to the direction of incident ray, then it should be considered as negative. For example, here this is pole and you want to measure focal length. Pole to focal length we have to measure, because according to the first law, pole to focus is nothing but focal length, and focal length you should measure from only pole. Pole to F, when you are measuring, you will be coming opposite to the incident ray direction, because this is incident ray is falling like this, because object is in front of the concave mirror and we measure from the pole to focus. That means we are coming opposite to the incident ray direction. Incident ray is going from my right hand side to left hand side. When you measure focal length, the distance we are starting from pole to focus, that means left to right we are coming. So both are opposite to each other. If our distance, our measuring distance, it may be a focal length, or it may be a object distance, or it may be a image distance, or it may be a radius of curvature, any distance must measure from the pole. While measuring like this, if the direction is you're taking is opposite to the incident ray direction, as we have taken here now, then we should consider it as that distance is as negative. Suppose image is formed here. For example, suppose in one case like concave mirror we have an image here, okay, right? Suppose image is formed here and you need to measure only from the pole. According to the first rule, sign convention first rule, we need to measure from pole. So where we will start, from pole to image will go like this, and our direction is from right to left only. Our incident ray direction is also from right to left only, and both of them are same. That time we have to consider this distance as positive. I hope you understood. I repeat, if a distance is measured opposite to the incident ray direction, it should be considered as negative. If the distance is along with the incident ray direction, then we should consider as positive. This is our second rule. And the third rule of sign convention is, the distances we will take from the principal axis. For example, the height of the object. We have talked till now, we discussed about only horizontal and distances from left to right and right to left. This is object distance and image distance. If the object distance is from the principal axis, if you consider it as upward direction, then it should be considered as positive. From the principal axis, if you measuring the distance, even we have to measure only from principal axis. When you measure from principal axis, if the image is downward, then this height, the size should be considered as negative. Height of the object, according to that third rule, height of the object is, it is above the principal axis, it is taken as positive, and this one considered as negative because it is below the principal axis. That's why the height of this image is negative. I hope you understood sign convention rules. If you clear with this, we can discuss, we can go for the derivation of mirror formula. So, to discuss about this mirror formula, we need to understand the points here, some angles also. Let us see, this is a concave mirror and this is a pole. This is P dash. I will talk to you about this. This is F is focus, and this is I in image, and this C is center of curvature, and this O is a object. Till now we draw the ray diagrams for an object which is extended, that means which has a little bigger in size when we keep on principal axis. But this object here we are considering as a point size object. It is not extended object, it is a point sized object, and this point size object is placed on principal axis. Is placed on principal axis beyond the center of curvature. You can observe here, this object is beyond this center of curvature. So according to our previous ray diagrams, what we have learnt, when an object is placed beyond the center of curvature, then where do we get image? We get, yes, we get image between F and C. This is F and this is C. We get image between F and C. It's not compulsory to take only exactly between F and C. It is anywhere between F and C we can take. So here we get image between F and C. So here to draw the ray diagram, for example, if you take a C here, to draw the ray diagram, how to draw a ray diagram? Simply for example, it is a point like this, that's it, and here we have a concave mirror. From this point, how to draw the ray diagram? We need to take two rays. One ray is like this, we are considering one ray is like this, the other ray we are considering along the principal axis. These are the two rays. Why we have to consider two rays? Why we have to consider two rays? Because two minimum number of incident rays are compulsory to get a image. If two incident rays are not there, we cannot get the intersection point of reflected rays. We know that the point where the two reflected rays intersect, there we get the image. So here the incident ray is taken one here, and the other incident ray we are taking along the principal axis. Let's see where do we get the image. Incident ray you can see here in blue color. It is falling on a mirror. What will happen? It will reflect, obviously, because it is a concave mirror. It is reflecting like this. Pink one is reflected ray and blue one is incident ray. Incident ray reflected in pink way. Okay, clear? And this green dotted line you can see, this is normal. Everybody know how to draw the normal. In first class we have discussed in lecture 1. Any point on the concave mirror is joined to the center of curvature, that is called normal. You know center of curvature, and anywhere here we are taking, because incident ray is point of incidence is here at the A. That means incident ray is touching mirror at A point. So here only we are drawing normal, because at point of incidence only normal should be there. According to second law of reflection, incident ray, reflected ray, normal all lie on the same plane at a point of incidence. So that's why it is a normal. Normal, it is in dotted line. Everybody try to understand, very easy. Incident ray, one incident ray, and it is reflected like this and touching the principal axis. And why we are stopped till here only? Why we didn't extend this reflected ray? Because the second incident ray taken along the principal axis. You can take anywhere, but two minimum incident rays are required. When any incident ray travel along the principal axis, what we have learnt? There will be no deviation in reflection. The reflected ray will be retraces its path in this way. There will be no deviation. It reflected ray retraces its path. So this will be the reflected ray direction. I hope everybody understood. This is the reflected ray direction. Incident ray is falling on concave mirror here like this and reflected like this. So why it is reflecting? Again, in lecture number 1, first homework question I gave you. If any incident ray falling on normal or along the normal or along the principal axis, then there will be no deviation. It will retrace its path. That's the reason this is incident ray direction, fall on mirror, and again reflecting back. This is only reflected ray. So this is one reflected ray and this pink one is another reflected ray. Both of them are intersecting at this point. Obviously the intersection point of two reflected rays gives us image position. So this is the image. and the image anyway it is diminished, because if the object is beyond C, the image formed between F and C, what is the nature of the image we have learnt in previous ray diagrams? If the object is beyond C and image formed between F and C, right, and the image size is diminished, that means smaller than the size of the object. Anyway this object is point sized, so that the size of the image will be diminished and smaller than this point. So here we get image. Till now it is clear, everybody? And let's see the angle of incidence. According to laws of reflection, angle of incidence is equal to angle of reflection. Yes or no? It is not only for the plane mirrors, even for the curved surfaces also it is true. It is valid, the laws of reflection. So here, what is angle of incidence? You must learn all these definitions I told you in lecture 1. What is angle of incidence? Angle of incidence is the angle between incident ray and normal. Blue colored one is incident ray and dotted line is normal. The angle between incident ray and normal is called as angle of incidence. And here the angle between reflected ray and normal is called as angle of reflection. And here for the both of the values we gave theta only. Why we have given theta? Because angle of incidence and angle of reflection, according to laws of reflection, both are equal. So theta and theta, angle of incidence and angle of reflection, both are equal. That's why it is indicated by theta only. Let's come for this angle, alpha. What is this alpha? This alpha is angle between incident ray and principal axis. Principal axis and incident ray, between this two angle is alpha. And angle between incident ray, so this principal axis and normal is beta. Angle between normal and incident ray is beta, and angle between principal axis and reflected ray is gamma. These are the values, alpha, beta and gamma. I think everybody understood picture diagram. Ray diagram is very important. Let us see what is image distance. Image distance is the distance between pole and eye. The distance between pole and eye called image distance, that is indicated as V. Let us distance between P and I is nothing but what? Image distance. Image distance is indicated by with letter alphabet V. And can you tell me what is the sign convention for this? Yes, this is incident ray, it is going like this and we are going like this, because to measure this image distance we need to measure from the pole. According to first law of sign convention, we are going from the pole. Pole to eye is image distance, and it is positive or negative? Negative. Why it is negative? Because incident ray direction is from right to left, but for the PI, for the distance, image distance, it is from left to right. So both of them are opposite to each other. That's why PI is negative. So it is minus V. And what about PF? Between pole to focus is focal length. The distance for focal length should be measured from pole, and it is also opposite to the incident ray direction. So focal length also should be considered as negative. What about PC? What is called PC? PC is nothing but radius of curvature. The distance between pole and center of curvature is radius of curvature. So this radius of curvature is also negative, because opposite to the incident ray direction. And the distance between pole and object is also negative. Why negative? Because incident ray direction is like this, and again we are going opposite to the incident ray direction. If we go opposite to the incident ray direction, it should be, the distance should be taken considered as negative. So all of the distances are negative only. I hope everybody understood. These sign conventions are very much important, even because I told you in first lecture, this sign convention even we use in 4th lesson and even 5th lesson also. And the sign conventions, without sign conventions you cannot do any problem, because all the problems are related to sign conventions. If one plus or minus is changed, so all the problem will become wrong. So understanding sign conventions is very much important, and it is easy also. I hope everybody understood. Okay, let's go for the derivation part. I already explained all this. what is O, what is and this is the point A. We have to discuss this. A is nothing but a point of incidence. From A to this point is projected on principal axis. This is P dash. That means this point, when we project downward, vertically downward, the point A is touching principal axis at P dash. Sometimes we do not consider P dash and P are different. We consider P and P dash are same because the distance between them is very minimum distance, so this distance will be negligible. Whenever you consider AP dash, we will consider only P, right? AP only we will consider. In later classes we will see that. So this is the theory part. Those who are preparing a notes, write a notes for this. This is the notes, and let's go for the derivation. AC is the normal. We have seen that also. AC is normal only, no? This is A and this is C. Point on mirror is joined to center of curvature. Very important. Point on any point on the mirror joined to the center of curvature is called as normal. Any point on the concave mirror is joined to center of curvature gives us what? Normal. So AC is a normal here. And you people know what is angle of incidence? OAC. OAC is a angle of incidence. In the same way, CAI is also angle of reflection. I repeat, OAC is theta, that is angle of incidence. CAI, that is also theta only, but it is angle of reflection. As from the laws of reflection we know both of them are equal, that's why for our convenience we consider both of them are theta only. Angle OAC, angle CAI, both of them are angle of incidence and angle of reflection respectively, and both of them are equal. Let's see here. OAC is equal to angle I, that is theta. Angle CAI is equal to angle of reflection, that is also theta. Both of them are equal from laws of reflection. A is perpendicular, AP dash is drawn from point A to the principal axis. I told you just now. We can observe three right angle triangles, namely AOP dash, ACP dash, AIP dash. Let us see what are the three triangles. AOP dash, AOP dash, ACP dash, AIP dash. I repeat, these are the three triangles we are using to derive the mirror formula. AO, we can see AO P dash, big triangle, AO P dash. Next one AC P dash. Next one AI P dash. Very easy. AP dash is perpendicular. You just see AP dash is perpendicular. You need to take AO P dash, big triangle. You can see. And the next smallest triangle, next triangle AC P dash. Next triangle AI P dash. These are the three triangles we are considering to derive the mirror formula. So if you take angles at different vertices, we have seen already O, C, I explained. At O we see alpha angle, at C vertices we see beta angle, at I vertical we see gamma angle. So we have alpha, beta, gamma. Where do we get angles? These are the angles which are made by the incident ray, principal axis, normal and principal axis, and reflected ray and principal axis we got. At the vertices of OCI we get these angles. Let us see, in a triangle, any triangle, sum of the interior angles equal to exterior angle. We know that. Sum of the interior angles, what are they here? Alpha and theta are interior angles, right? If you consider this triangle ACO, if you consider, this is an exterior angle, and this is beta is exterior angle, theta and alpha are interior angles. So sum of the interior angles in a triangle is equal to the exterior angle. So interior angles are here theta and alpha. So alpha plus theta is equal to exterior angle is here beta. So theta plus alpha is equal to beta. In the same way here beta is equal to alpha plus theta, right? If you want to know theta, if you want to calculate theta, what you have to do? This theta will be here and alpha will be that side. Theta is equal to beta minus alpha, right? From ACI triangle, let us see triangle ACI. A small triangle AC, second triangle ACI. In this triangle, what is this? Interior angles are what? Theta and beta. Interior angles are theta and beta, and these two angles sum is equal to exterior angle. Sum of the interior angles in a triangle is equal to exterior angle. So theta plus beta is equal to gamma. So we got two angles relation. According to sum of the interior angles is equal to exterior angles, we got two relations. Beta is equal to alpha plus theta. Next one gamma is equal to beta plus theta. This is from triangle ACI and this is from triangle AOC. I hope everybody understood this. Very easy. Take one triangle, see what are the interior angles and equal to exterior angle. Take another triangle ACI. What are the interior angles you see? It must be equal to, sum must be equal to exterior angle. Right? Now substitute this theta value. Substitute the theta value. Theta is what here? Beta minus alpha. Theta is nothing but beta minus alpha. This beta minus alpha value substitute in this place. Gamma is equal to beta plus theta we have. Substitute this theta value here in this place. So gamma is equal to beta plus theta. But theta is nothing but beta minus alpha. So beta plus beta is what? 2 beta. 2 beta minus alpha. So gamma is equal to 2 beta minus alpha. But 2 beta is equal to gamma plus alpha. Right? This is one relation we have. In previous one I have told you when h becomes very small, p dash coincide with point P. I told you here when h becomes, this is h, if you consider this is h, if h becomes small then p and p dash both will coincide. So whenever we have a p dash I, we can say pi because both of them are not having much distance. So we do not consider this distance, we neglect this distance. So p and p dash will be both same only. So p dash I wherever you have, you can write pi. If you have p dash and c, you can write pc like that. Let's see that. So p dash O will become what? PO. P dash C will become what? PC. P dash I become what? PI. Because both of them are having paraxial rays, we say both of them do not have much distance. And let us see from angles alpha, beta and gamma become very small. When alpha, beta, gamma values are very small, we can consider like this. See, take a triangle. Let us write tan alpha. Actually, you will get all these things in a trigonometry in 10th standard. For that term, I will tell you what is tan alpha. Tan alpha is nothing but, see, if you consider any right angle triangle, we will have a diagonal, adjacent side and opposite side. We have a trigonometric angle, 6 trigonometric angles we have. Those are sine, cos, tan, sine angle, cos angle, tan angle, tan, and cosecant, secant and tan, cot. So these are the 6 trigonometric angles we'll say. So we will consider tan. So for this derivation, we require tan. So for that I will tell you tan. What is tan? Tan is nothing but, this is a 90 degrees line. Everybody know that. When it is 90 degrees, this is the angle. So opposite this side, whatever it is there, this is called opposite side. And this is adjacent side. And this is hypotenuse or diagonal. So when you write a tan angle, you need to write opposite side by adjacent side. That's it. You remember that only. Tan angle is nothing but opposite side by adjacent. What is opposite? H. What is adjacent? This one. Anywhere. Whichever triangle you consider, that one will come. For example, you are considering AP-O. Big triangle. Here biggest triangle is what? AP dash and O. So in this AP-O, you are writing for tan alpha. So what you write tan alpha? Opposite side by adjacent side. What is opposite side here? AP dash. But as we consider P dash will be neglected. So it will become what? AP. AP by PO. That's it. That is for tan alpha. Say now tan beta. Tan beta is again what? Opposite side by adjacent. The next is bigger triangle. Opposite what? AP. Divided by what? PC. Opposite by adjacent. AP by PC. Next triangle is what? Gamma. Angle is gamma. So next triangle will write for this API. So tan gamma is equal to what again? Opposite by adjacent. AP by PI. That's it. For different we have 3 vertices here. I vertices, C vertices and O vertices. So for the different vertices we have different angles. For all these angles we are writing tan. Trigonometric angle tan. So that one we have done here. So tan alpha is equal to P dash I by P dash. We don't consider P dash, so we'll write PA. PA by PO. What is PA? PA is nothing but H. PA is nothing but H, height. So H by PO. Tan beta is what? I told you. P dash. P dash we don't consider, we'll take only P. PA by PC. PA by PC means what? H by PC. P dash A by P dash I. This is tan gamma. So that what? H by Pi. I told you know what is Pi, P dash A. P dash A is nothing but H. Wherever you get P dash A, you need to write H. So write H here, and then Pi dash we have to P dash anyway we don't consider. P dash also considered as P only because of very less distance. So Pi. So H by PO, H by PC, H by Pi. These are the trigonometric angles. What is tan? Nothing but tan is nothing but a trigonometric angle. The formula is opposite side by adjacent side in a 90 degrees right angle triangle. So tan alpha what we got now? Tan alpha is equal to H by PO, tan beta is equal to H by PC, tan gamma is equal to H by PA. As alpha and beta gamma are very small, we remove this tan and we'll make it alpha is equal to H by PO, beta is equal to H by PC, gamma is equal to H by PA. So these are the alpha, beta, gamma values. So again we have a relation here. We discussed the relation we got from exterior angles, interior angles. We got one relation. What is that relation? 2 beta is equal to gamma plus alpha. 2 beta is equal to gamma plus alpha. This 2 beta is equal to gamma plus alpha we'll take here. Because we know what is beta, what is alpha, what is gamma. We obtained now all the values. So we need to substitute in place of beta H by PC. Because alpha, beta, gamma values are here we have. Alpha value is what? H by PO. Beta value is what? H by PC. Gamma value is what? H by PI. So substitute these values. H by PC is beta, alpha value is H by PO, gamma value is H by PI. So what is H actually? 2 into these all H's na? All H's are in the numerator. So cancel all the H. H cancel here, H cancel here, H cancel here. So we have 2 by PC, 1 by PO, 1 by PI. So 2 by PC. What is PC? We'll see now. We already know that. PC, PO, PI. Let us see what is PC. PC. Distance between pole and center of curvature. What is that? Distance between pole and center of curvature is? Yes. Some of you got answer. What is PC? Yes. Distance between pole and center of curvature is called as radius of curvature. So PC is nothing but R. What is the distance between P and O? Yes. The distance between pole and object is object distance. That means U. Object distance is denoted by U. And what is P and I? Distance between pole and image. That is image distance. Image distance is denoted with alphabet V. So V, capital R and U. These are the distances. And we need to follow sign conventions also. Starting of the derivation we understood now how to take PI also negative, PC also negative, PO also negative. Because all of the distances are away opposite to the direction of incident ray. So all of them must be considered as negative according to sign convention rules. So now we have all of them are negative. So 2 by PC is nothing but R, PO is nothing but U, PI is V. 2 by minus R, minus 1 by U, minus 1 by V. So if you cancel all these minus, we get 2 by R is equal to 1 by U plus 1 by V. What is R? R nothing but radius of curvature. First class I told you, radius of curvature is always double of the focal length. R is equal to 2F. This is F. Small f is focal length, capital F is focus. So 2 by 2F, 2 gets cancelled. Where do you get 2 here? From this 2B. So 2 gets cancelled. So 1 by F is equal to 1 by U plus 1 by V. This is called mirror formula. Hence mirror formula is derived. I believe everybody understood. Very easy derivation. 1 by F is equal to 1 by U plus 1 by V. If you practice, easily you will get this derivation without any doubt. Practice, see the ray diagram and do it. See the ray diagram and do it. Step by step you follow it. Only the new thing what you have learning here is trigonometric angle. That is tan angle. We have sine, cos, tan, cot, cosecant, secant. But no need to learn all now for this derivation. Just learn what is tan theta. Tan theta is nothing but, I am writing here, Tan theta is nothing but opposite side by adjacent side. Opposite side by adjacent side. What is opposite side? What is adjacent side also? I'll do here. If you consider this is a right angle triangle A, B, C, and this is 90 degrees, and this is some theta angle. So this is opposite side, and this is adjacent side, and this is hypotenuse. So tan angle, if you want to write, what will become? Tan theta is equal to opposite by adjacent. That is nothing but opposite is what? AB. Adjacent is what? BC. AB by BC. This is tan theta information. If you know this, it will be easy for you. Okay, this is mirror formula. We use this mirror formula to get or to know or to solve numericals. They will give you f and u value, we need to find out v value. Otherwise they will give you f and v value, we need to find out u value. So from this we can easily obtain, not only to solve the problems, we can easily understand what will be the nature of the image. Where do you get the image? What is the size of the image? How the size of image is changing? These all we are going to learn. These are the sign conventions. You can prepare a notes and learn. Better you prepare notes thoroughly, easily you can learn from the notebook. Next one, magnification. Magnification is nothing but it is actually a ratio of the size of the image to size of the object. See, in general terms I will tell you what is magnification. For example, you use a microscope, amoeba, paramecium. In biology you use microscope. In the microscope what we observe? A very tiny object appears as a very big object. Even dentists use concave mirror. What he trying to see? He will see a very small tooth into a big tooth so that he can understand where is the cavity. So for clear observation, the microscope or the magnifying glass can be used, or a concave mirror can be used. So how much the size is becoming, whether it is becoming big or becoming small, to know, how to know, from where to know, is telling in the definition of magnification, concept of magnification. Magnification is a ratio of size of the image to size of the object, or also we can say it is a ratio of the image distance to object distance. The formula is m is equal to minus v by u is equal to hi by h naught. This is also another definition, another derivation. For this derivation we consider an object beyond the center of curvature. Object is beyond the center of curvature. This is OO dash. Till now we used object as a candle, right? Now next from this onwards we consider only the arrow only. Even while you draw ray diagrams you have to use only arrow. So OO dash is an object and C is the center of curvature. Whatever I am pointing now, you just see that only. Don't see all the diagram. OO dash is an object and it is placed beyond the center of curvature, and this is the focus and this is pole, right? Now to draw any ray diagram, the minimum number of rays required are 2. 2 minimum number of incident rays are required. So we will be getting 2 reflected rays, and the point where the 2 reflected rays get meet, there we will get the image. So here incident ray considered as parallel to principal axis. According to rule, if any incident ray is parallel to principal axis, on mirror it will get reflected and passing through focus. This pink one is reflected ray for this ray. This is first ray, incident ray, this is first reflected ray. And the second incident ray I have taken which is falling on pole. Any ray which is falling on pole, for this condition principal axis act as a normal, so that it will make equal angle with incident ray and normal. How much angle it is making? The same angle it will even make with the principal axis and reflected ray. So this will act as a normal. So this is the reflected ray. And 2 reflected rays which are in pink color intersecting at this point. So we get image. You see the diagram clearly. It is very easy. This is incident ray 1. This is incident ray 2. Incident ray is passing parallel to principal axis. After reflection it will pass through focus. It is passing like this. And the next one is falling at pole without any changing angle. How much angle it is making here? It will make the same angle even here, because it is making angle with principal axis. So that principal axis is acting as a normal. So here angle and here angle both are same. Here there is no point in discussing about the angle, but I am telling you what is happening here, how the reflection is taking place. So these are the pink color one, two are reflected rays. So the intersection point, at this point we get the tip of this object. So this will be I dash and this will be the I. If the object is beyond the center of curvature, then we get image between F and C. We got image, and the image size is diminished and also real and inverted. This is the case we are considering to derive the magnification formula. So the magnification formula, to derive the magnification formula, we are taking a triangle POO dash. See here, POO dash, and the next triangle PII dash. Two triangles. From these two triangles, we are writing again tan theta. If you considered this one as theta, tan theta if you take here, then this will become opposite side and this one will become adjacent side, and it is a right angle triangle. POO dash. You can see POO dash, this one. POO dash. From this, it is a right angle triangle. Here is the angle theta. If you want to write tan theta, this is opposite side by adjacent side. Opposite is OO dash, adjacent is PO. And next one, the next other triangle we consider as PII dash. This is the small triangle. Small triangle PII dash. From PII dash, tan theta is equal to opposite side by adjacent side. PII dash is the opposite side and PI is the adjacent side. Opposite side by adjacent side. II dash by PI. So now this also theta, this is also theta, right? Why both of them are theta? That's why you have to learn laws of reflection first lecture. I told you laws of reflection, angle of incidence, angle of reflection, normal, focal length, radius of curvature, angle of incidence, definition, image distance, object distance, radius of curvature. These all definitions are very important. You need to learn. If you learn, then only you can substitute these values, and what we have to substitute, where we have to substitute. So this and these are both, see, when he wrote tan theta here, tan theta wrote, and we are making equal both of them. Why we are equating both of them? Because we are equating both of the values, because this is angle of incidence, this is angle of reflection. This is incident ray, normal. This is normal, reflected ray. The angle between incident ray and normal is angle of incidence. The angle between normal and reflected ray is angle of reflection. So both of them are equal according to laws of reflection. That's why we made equal. II dash by OO dash is equal to, now we take II dash, keep it here, let this OO dash come this side, and PI is going that side, PI by PO. This is third equation. We are deriving formula. So this PO is nothing but, we know distance between pole and optic center is object distance. Distance between pole and I is image distance. OO dash is height of the object. II dash is height of the image. I will show you what is OO dash and II dash. You know PI and PO, right? Let us see what is OO dash and II dash. OO dash is height of the object. II dash is height of the image. Clear? Okay. Let's substitute all the values. This is II dash, OO dash is equal to PI by PO. We know what is II dash. II dash is nothing but HI, height of the image. Why it is considered as negative? Because image is inward. That means that is inverted. Image is inverted, that's why HI is negative. Then U and V, why negative? Because the distances are measured from the pole and all the distances are opposite to the incident ray direction. If the distances are opposite to the incident ray direction, it must be considered as negative sign. But why not H naught? Why not H naught is not negative? Because H naught is nothing but height of the object and it is above the principal axis. If the heights are above the principal axis, those are considered as positive, and heights below the principal axis considered as negative. So this is positive and this is negative. So these are the values. Along with sign convention, we need to substitute here. II dash by OO dash is equal to PI by PO. So this is minus HI by H naught is equal to II dash is HI, OO dash is H naught, HO. Height of the image, height of the object. Image distance, object distance. This minus and minus, both of them gets cancelled, and minus taken to this side. Hi by h naught is equal to minus v by minus u. This is called magnification. Depending upon magnification, there are many questions. We are going to discuss all those questions in the next class. You people learn this and get ready for the next class. Have you and thank you. Have a nice day.